Welcome. This is the SDSFIE-V Subclasses and Esri Subtypes webinar, a resource for SDSFIE training. This training resource is designed for all users who want to learn about SDSFIE-V subclasses and Esri subtypes. The prerequisite for this webinar is the Understanding the Vector or V standard webinar. The overall goal for our training resources is that all SDSFIE users understand the purpose, structure, and parts of the SDSFIE family of standards and how to implement those standards. The specific objectives for this presentation are that the audience gains an understanding of the following: what an SDSFIE-V subclass is, what an Esri subtype is, and how they are the same and how they are different, the structure of subtypes and subclasses, and their relationship with those elements above them in the hierarchy, such as entities, and below them, such as attributes and enumerants, examples of subclasses and subtypes, implementation benefits of subtypes, and issues and post-creation actions for subclasses. A subtype is one element from a set of concepts that fit within a broader parent entity concept. The purposes of subtypes are to categorize data and to allow for different data representation and implementation functions in ArcGIS without the burden of having a separate feature class for every element in that set of extended concepts. All the subtypes for an entity share identical attributes. Each subtype is defined by the value taken on by a subtype attribute, which must have an integer data type. Those values are specified in the subtype code property of an enumerant in an enumeration that constrains the subtype attribute. A subclass is a single specialized, or narrowed, concept from that of the broader parent entity concept. The typical purpose of a subclass is to add one or more attributes to the entire set of inherited parent attributes. The basis for specializing a subclass can be either A, one of the types of the permissible geometries of the parent entity, or B, the basis attribute value that is an enumerant in an enumeration that constrains the basis attribute. This table summarizes the structure of subtypes and subclasses relative to SDSFIE-V elements, and also their ArcGIS implementation details. In the second column, we see that the set of subtypes for an entity are defined by each of the enumerant types in an enumeration that constrains the subtype attribute. No new element type is created, and no new attributes are added. In ArcGIS, subtypes are expressed within a single feature class, where default values of any attribute in that feature class can be automatically set in a subtype-dependent manner. The structure of subclasses are defined in the third and fourth columns. For subclasses defined by a basis attribute, the value comes from a single enumerant in an enumeration that constrains that basis attribute. For subclasses defined by geometry type, the defining feature is simply one of the permissible geometry types of the parent entity. In both cases, attributes are extended beyond those assigned to the parent. In ArcGIS, each subclass is expressed as a different feature class, and no special implementation functions are afforded. In a moment, we will come back to this table to summarize the structure of the example subtypes and subclasses of the golf course feature entity that we will look at now. Our first examples are two subclasses. Shown here is a representation of the logical data model, or LDM, as shown in the prerequisite Understanding the Vector or V standard training video. These examples are based on the golf course feature type, which can be implemented in any of the three geometry types. In addition to its foundational and real property attributes, not shown here, golf course feature contains one attribute, golf course feature type. That attribute is constrained by the golf course feature type enumeration, with a set of enumerant values that describe each of the primary features that you would expect to see on a golf course. With that information in hand, we can specify our requirements for the example subclasses as shown in the extensions table. Subclass number 1, named Water Hazard, is attribute-based. It uses golf course feature type as the basis attribute, with water hazard as the basis attribute value. This subclass adds a has alligators attribute to the set of attributes inherited from the golf course feature parent. Subclass number 2, named golf course area, is geometry-based. It uses area as the basis geometry type and adds an isMode attribute to the set of attributes inherited from the golf course feature parent. Our third example is the subtypes of the same golf course feature entity. In this case, all of the enumerants of the golf course feature type enumeration correspond to a subtype. There are 3 requirements that must be satisfied for SDSFIE-V subtypes to be successfully implemented in ArcGIS. 1. As stated when we defined what a subtype is, the subtype attribute must have an integer data type. 2. The enumeration that constrains the subtype attribute must have a string or integer data type. 3. The enumerants must be coded integer values. Examining the example, we see that the existing attribute with the needed enumerant concepts has a data type of string, not integer, that the enumeration is also string, and that the enumerant concepts are not coded as integer values. Thus, we need to add another attribute of data type integer and add a set of subtype codes for those enumerant values so that the enumeration can be used to constrain our new subtype attribute. In this view of our example subtype, we have added a new attribute, golf course feature subtype, that will serve as the subtype attribute. Its data type property is set as integer, as required, and it is also constrained by the golf course feature type enumeration. To each enumerant in that enumeration, we have populated the subtype code property with integer values for the definite enumerants representing the types of golf course features, and standard coded values from Esri for the indefinite enumerants as shown in the table in the lower right. Let's step back and take a quick look at the structure of our example subtype and subclasses. For our subtype, because golf course feature type was a string, we had to add a new attribute golf course feature subtype, set it as integer, and assign subtype codes to the enumerant concepts, each of which represent a category of a single feature class in Esri. For our attribute-based water hazard subclass, we simply specified golf course feature type as the basis attribute and water hazard as the basis attribute value. To the new entity that was created and represented as its own distinct feature class in Esri, we added the new required attribute named has alligators. For our geometry-based golf course area subclass, defined by the area value from the set of permissible geometries, we added an isMode attribute to the new entity that was created and represented as its own distinct feature class in Esri. As noted, for an ArcGIS feature class with subtyping, default values of any attribute in that feature class can be automatically set in a subtype-dependent manner. Here we see how values of polygon records in the golf course area feature class are populated according to the particular subtype. When new polygons are added to the feature class and the subtype is specified, then values of the isVegetated attribute are set to true for areas with grass, and the mowing level and frequency values are set in a subtype-specific manner. Before wrapping up, let's consider some potential issues when creating adaptations that contain attribute-based subclasses. First, in the typical case in which the parent entity is retained in the adaptation, the enumerant used as the basis attribute value of the subclass is still present in the enumeration in that parent entity. The problem is that the enumerant value should only be applicable to the subclass. For example, while the water hazard value could be selected to populate the golf course feature type attribute for a record in the parent, it should only populate that attribute in the subclass water hazard. After the subclass is created, that enumerant concept should only be stored in subclass records, not records of the parent entity. Second, using the golf course feature type basis attribute at all in the subclass is unnecessary. The subclass is named water hazard, and there is no reason to have an attribute populated with a water hazard value. unless there is a need to consolidate the parent and subclass feature classes, such as for data rollup or reporting. Third, in a feature class generated from the subclass, the basis attribute should be populated only with the basis attribute value, for example, water hazard. The SDSFIE vector implementation guidance provides two options to address these issues in the adaptation. Option 1 has two parts. A. Profile the basis attribute value, for example the water hazard enumerant, from the enumeration, and B. Profile the basis attribute, for example golf course feature type, from the subclass. Option 2 is to set the basis attribute value, for example water hazard, for the default value property of the basis attribute in the subclass. To wrap up, let's compare and contrast subtypes and subclasses, starting with the similarities. In the LDM, both are derived by limiting the scope of the parent entity. In the LDM, both can be defined on the basis of an enumerant concept of an enumeration that constrains an attribute in the parent entity. As for the differences, fundamentally, a subtype is created and defined in the SDSFIE-V LDM entirely for the purpose of implementation as an Esri subtype element, whereas a subclass is implemented in Esri like any other entity, as a feature class. A subclass is represented as an entity in the LDM, with a superclass property populated with the parent entity name, but with a distinct model name, alias, and definition. Conversely, a subtype is not a separate entity in the LDM. It is defined at the entity level by one of the set of concept values that populate the subtype attribute. So, congruent with the LDM, in the physical data model, or PDM, a subclass is implemented in a geodatabase as a feature class or object table, whereas a subtype of an entity becomes a subtype of a feature class. And the final difference, all subtypes of an entity have the same exact set of attributes, those of the parent entity, whereas subclasses inherit the parent entity's attributes, but also typically add attributes that support the specialized use. This concludes the SDSFIE-V subclasses and Esri subtypes presentation, an SDSFIE video training resource. The follow-up training topic dealing with the implementation of what we have learned in this video is Model Builder, Subclasses, and Subtypes. If you are not familiar with the Model Builder application, you will likely now want to watch the 4 videos listed here. If you want to learn more about SDSFIE, its governance and use, or more detailed SDSFIE topics, visit our training resources page at the URL listed here. Thank you for your interest in SDSFIE.